Welcome to qnawire.
Over here we have diphenylamine, which is a compound containing carbon, hydrogen, and nitrogen in its structure, and the combustion is going to generate CO2, H2O, and nitrogen as products. So we're told that the combustion of 9.71 milligrams of diphenylamine is going to generate 5.68 milligrams of water and 0.8 milligrams of nitrogen gas. With this information, we want to know what is going to be the empirical formula. So the first step that we're going to do is transform these quantities into amount of mole of hydrogen and amount of mole of nitrogen that we're going to have. First of all, for the amount of mole of hydrogen, we're going to begin with 5.68 milligrams of water that is being produced. We know that 1000 milligrams corresponds to 1 gram of sample, 1 gram of whatever, in this case 1 gram of water, and the molecular weight of water is going to be 18 grams per mole. From here we know that 1 mole of water corresponds to 2 mole of hydrogen. So over here, what we're going to get is 5.68 divided by 1000 divided by 18 and multiplied by 2 as 6.31, 311 times 10 to the minus 4 mole of hydrogen in the molecule. This is going to be the very first important result that we have. In addition to that, we know the amount of mole of nitrogen contained in the molecule is going to be equal to 0.80 milligrams of N2, the same conversion factors. 1000 milligrams is 1 gram of N2. In the case of nitrogen, we know that N2 is going to have a molecular mass of 28 grams per mole. Is 1 mole of N2. And 1 mole of N2 contains 2 moles of nitrogen atoms. So we're going to get 0.8 divided by 1000 divided by 28, and the final result multiplied by 2, 5.714 times 10 to the minus 5 mole of N2. Okay, so now with this information, what we can get is the mass corresponding to nitrogen and the mass corresponding to hydrogen that we're going to have. And we're going to find those masses in milligrams because we know that the total amount of sample is 9.71 milligrams. Knowing this is going to allow us to calculate what is going to be the mass corresponding to carbon. Okay, so for the mass of nitrogen, we're going to begin again with the amount of mole. Sorry, in this case is of nitrogen atom, not of N2. Okay, we're going to begin with the amount of mole of nitrogen that we have, and we know that 1 mole of nitrogen is going to have an atomic mass of 14 grams. In addition to that, 1000 milligrams corresponds to 1 gram. So the result over here would be 0.8 milligrams. This is going to be the mass corresponding to nitrogen. In the case for hydrogen, this is going to be more simple, 6.31 times 10 to the minus 4 mole. The mass is directly 1 gram per mole of hydrogen. And the conversion factor, again, 1000 milligrams divided by 1 gram. This is going to give us 0.63 milligrams of hydrogen. So that means that the mass of carbon is going to be equal to the total mass minus the mass of nitrogen minus the mass of hydrogen. This is going to be, the total was 9.71 milligrams minus 0.8 minus 0.63. This is going to give us 8.28 milligrams of carbon. Now, with this quantity of carbon, we can calculate the amount of mole of carbon, which is going to be 8.28 milligrams coming from carbon, the conversion factor from milligrams to grams. Next up, we know that carbon is going to have an atomic mass of 12 grams per mole, and this is going to give us our result. So this over 1000 over 12, 6.9 times 10 to the minus 4. Corresponding to carbon. So now we can write down our table. We're going to have amount of mole of carbon, and amount of mole of nitrogen, and amount of mole of hydrogen. In this case, of carbon is 6.9 times 10 to the minus 4 mole. Of nitrogen is going to be 5.714 times 10 to the minus 5. This is going to be the lower amount. And of hydrogen is going to be 6.311 times 10 to the minus 4. Now we're going to divide each of them by the lowest quantity. So in this case, the lowest value is going to be, let's put over here the operation. We're going to divide by 5.714 times 10 to the minus 5. And this is going to give us the ratios. For nitrogen, we're going to get 1 directly. For carbon, we're going to get 12. And in the case for hydrogen, we're going to get 11. So this is going to tell us that the formula for this compound is going to be C12H11N. This is going to be our empirical formula. And this empirical formula corresponds to a molar mass of 169 grams per mole, or atomic mass units, which corresponds also to the molecular weight given in the problem. So this is going to be 169 grams per mole, which is the same as 169 atomic mass units. That means that our empirical formula is also going to be the same as the molecular formula. C12H11N. So with that, it would be all. Thank you very much, and have a good one.